Welcome back to Hidden in the Stars. I apologize if I sound a little off. I am recovering from a cold. Yesterday at 2:19 p.m., astronomers marked the autumnal equinox and the end of summer. We want to wish a very happy autumn to our viewers around the world. Depending on where you live, the change of seasons brings sweater weather, pumpkin spice lattes, and fresh picked apples. For our viewers in the southern hemisphere, this time of year brings warmer weather and new flowers. Most people know that the change of seasons is caused by the tilting of the Earth on its axis. When your part of the planet is tilted more toward the sun, then you're experiencing summer. Conversely, when your hemisphere tips away from the sun, then you are in winter. The autumnal and vernal equinoxes mark the change to those seasons with days of nearly equal amounts of daylight and night. At the summer and winter solstices, the geographic pole has a maximum axial tilt of 23.5 degrees from the ecliptic, the orbital plane of the Earth around the Sun. At the equinox, this tilt becomes 0 degrees. Partly because of this lack of tilt, there is another occurrence associated with the equinoxes, an increase in auroral activity. As Professor Mike Lockwood, president of the Royal Astronomical Society, told BBC Weather, quote, "Your chances of seeing aurora at low latitudes is enhanced at the equinoxes because of the Russell-McPherron Effect." But what is the Russell-McPherron Effect? First named in 1973 by geophysicists Christopher Russell and Robert McPherron, this increase in auroral activity occurs because, at the equinoxes, the Earth's magnetic poles fall into approximately a right angle to the direction of the solar wind's flow, making the solar wind more potent. Side note, that's the 0 degree tilt we mentioned earlier, and yes, we are keeping in mind that there is a difference between the geographic poles of the Earth that point to true north and true south, and the magnetic poles, which are generated by electric currents in the Earth's iron core and can fluctuate slightly as a result. The magnetic poles still tilt with respect to the Sun. The Sun, currently at a maximum point in its 11-year cycle, releases solar wind and coronal mass ejections toward the Earth, which are pulled in toward the magnetic poles. During summer and winter, the axial tilt is sufficient to deflect much of the energy of these coronal mass ejections. During the equinoxes, the magnetic orientation is aligned perfectly in a process called magnetic reconnection and allows more solar wind to enter the Earth's magnetosphere. The result? A greater chance of auroras. As a consequence of this magnetic reconnection, we also experience more intense geomagnetic storms at the time of the equinoxes, as shown by this graphic. Notice that this is measuring storms with a KP index of 7 or higher. But what does that mean? The KP index measures the global strength of a geomagnetic storm and ranges from 0 to 9, respectively quiet, to extreme. If you look carefully at the numbers from 5 to 9, you will also see the NOAA G scales used more commonly in the United States. We have talked several times on this channel about the May 10th, 2024 geomagnetic storm that created amazing aurora displays at unusually low latitudes. That storm was rated as a 9 on the KP index and a 5 on the NOAA scale. This intriguing graphic from seetheaurora.com shows where the auroras can be seen by latitude depending on the KP index of the geomagnetic storm. As a note, we found that website to be fascinating and highly recommended for those viewers who wish to dive deeper. We will leave it in the description box. But what do you think? Have you noticed an increase in the aurora in your area recently? How much more of an impact do you think the May 10th, 2024 storm would have had on our planet had it happened at the time of an equinox? What about the Carrington event in 1859, which did happen closer to the autumnal equinox? We have made a video about that event, and we'll leave it linked. As always, we are interested in reading your thoughts and comments on the matter. Catch you next time on Hidden in the Stars.